Now, we've been talking about replacement analysis, and we always have been working under the assumption that our defender is going to be replaced by a challenger. However, that's not always the case. Sometimes you literally are not going to replace it and you're just going to get rid of it. And this can happen for several reasons, but maybe, I mean, a basic reason would be maybe you just don't, you're not going to create that part anymore. Or yeah, your technology has evolved so much that you're not even replacing it with something else. You're just getting rid of this altogether. So in any case, what's important about abandonment is you want to abandon your asset whenever it is when it's peaking, right? So we talked about the fact that if we look at a little, this would be money versus time. If we're looking from a cost perspective, this is purely cost perspective, an asset will typically do something like this, right? And there's this optimal point that we're looking at, and this is our economic life. It's a point at which our overall equivalent, so this is our EUAC, get minimized. Or if we're looking at annual worth, because you're taking benefits into account, then it would look like that, and the point would be at the same time, but the curve would look it would be the opposite. So in any case, what we want to do with abandonment is instead of replacing at this time, we're going to abandon it at this time so that it minimizes our cost or maximizes our profit. So let me erase that. So for projects having positive net cash flows that follow the initial investment and a finite period of required service, the question is, should the project be undertaken? And if so, we're going to be given market values, which are the same as abandonment values, because you can sell it at market price at any given point and not just choosing to not replace it. So the question is, what is the best year to abandon the project, and what is its economic life? So you're going to abandon it at the economic life. So this is similar to determining the economic life of an asset, but instead of benefits, but there will be benefits instead of costs that dominate. So what we're going to do is abandon the project or the asset the year that the present worth is at a maximum or before it starts decreasing. So here we have an example. It says a machine lathe has a current market value of $60,000 and can be kept in service for 4 more years. With a MAR of 12% per year, when should it be abandoned? The following data are projected for future years. So each one of these years, net receipts, remember that the word net right here means that both benefits and costs have already been taken into account, and this yields a positive number. And market value is the value at which we can sell the asset each year. However, the number that we're going to be considering, because this is what's happening right now, is this $60,000. So really, if we had a year 0 here, it would be 60K right there. All right? Okay, so how do we calculate this? Well, we are going to calculate the present worth for keeping it 1 year, 2 years, 3 years, 4 years, and figuring out which one is the best one. Okay, so although I have everything displayed, follow me. So if we keep for 1 year, the present worth is the following. We're going to use the market value at year 0 as a negative number because of opportunity cost. Either opportunity cost or outsider point of view. Remember, they're interchangeable terms in this case. So your opportunity cost is you did not make $60,000 because you chose to keep it. And therefore, we are going to add these two numbers as benefits because that means, remember, let's see. Nope, other way. So our net receipts are $50,000 and our market value is $35,000. That means that I'm going to be making $35,000 from the sale of the asset. I'm also going to be making $50,000 in receipts, and I can add these two quantities, and because I'm going to multiply both times P given F, 12 and 1. So I can do them separately, or I can just do them this way. It's kind of a distributed property type of thing, right? And what I get is 15,893. Okay, well, what if we keep it for 2 years? I'm still missing out on selling it for $60,000 right here. However, I am going to make in that year, in year 1, So this is my year one net receipts. So I'm still going to make those for having kept it. And this number, this $60,000, comes from the combination of the year two net receipts and the sale. Sorry, I lost my words for a second. Of the assets. So the 60,000 comes from 40,000 plus 20,000. The negative 60,000 comes from not having sold it at this price, but the positive 60,000 comes from that. And let's not forget the year one receipts, which will occur. And if we do that, we get a present worth of 32,474. So that's substantially better than the 50,000. However, what I'm going to find out from what you can see here is that year three is the best. Now, I didn't write it up, but year three, so let's cram it here. Year three would be equal to, okay, the present worth would be equal to negative 60,000. I'm going to use K for 1,000. Plus the 50,000, P given F, 12,1, plus the, what was it, 40,000, P given F, 12,2, plus, and here I'm going to add the 15 and the 15, so plus 30,000, P given F, 12,3. And we're going to find that this is equal to 37,884. For year four, we're going to do the same thing, except, 50,000 here, 40,000 here, only 15,000 here, but on the last year, it'll be 15, another 15, and that'll be P given F 12,4, and I'm going to get 36. Now, if you see 15, 32, 37, 36. So 15, 32, 37, 36. So at that 37, so this was year one, year two, year three, year four, and this was present worth. So this is the year where we abandon the project. That's how abandonment works. All right. That's all we have for this one. And continue the next one. We'll talk about taxes.